Hey there. So, thinking what we have made today here, this is actually a flame detector module. When I take a flame and get it near to the sensor, the red light here will be turning on. So, this is how we made a flame detector module. And please remember, while doing this, be careful with the fire things. So, yeah, let us start it. So today we have made very much simple. As we can see that we have just used a flame sensor module here. I'm using breadboard because it was hard to keep it on the ground. And we have used a resistor with an LED, which is red LED, and an Arduino. And if you see the connections, it is very simple. The connections, like the positive and negative of the sensor, is connected to the 5 volts and the ground of the Arduino, and the output pin of the sensor is connected to the pin number 2 of the Arduino, and the 13th pin is connected to the LED, which is output. So this is how we made this module. So now let us see the circuit diagram and learn how to code this module and how to make the connections. So connections are as shown in the circuit diagram. So as we have seen the circuit diagram, we might have got the idea about what all we need. So the all we need in this project is an Arduino, a breadboard, and a flame sensor module with an LED and a resistor. I'm using 220 volt resistor, 220 ohm resistor. You can use as per your convenience, and some jumper wires and a connector with a PC. PC is because we should give the power supply from the computer. So yeah, let us start with the connections. So now first I will fix this flame sensor module on the Arduino in this way. So yeah, and I will connect the power pins first. So that is 5 volts and the GND of ground pin of the Arduino to the VCC, or the I naught of the positive of the module, and the negative, that is ground. So in some modules it will be written like plus G and A naught and D naught, as we can see here, and in some modules it will be written like D naught, or something say related to that. So now we are using digital pin here, so we'll be taking the D0 pin of the sensor module. So yeah, now the 5 volts of the Arduino will be connected to the positive of the sensor, and the negative will be connected to the ground of the Arduino as well as the ground of the sensor module. And now the output pin here, which is pin number 2 of the Arduino, D2, we can say that D2 will be connected to the D0 of the sensor module. Yeah, so as we have seen the connection, like now we are almost ready. Now all we need is resistor, an LED with a resistor. So I'm connecting LED here, which is one side is anode and another is cathode. So bigger stick here will be anode and the smaller one will be cathode. So anode and cathode is nothing but the positive and negative. So I'll be connecting it here somewhere on the breadboard, and I'll take a resistor of 220 ohm, and I will fix it in the same way, in the same connection where the LED is there, because this LED cannot take 5 volts of current. It might get burnt. So the current which we are getting from the Arduino will be 5 volts. So to reduce that power, we are using resistor here. So after making the connection, now we will connect the LED. So that is positive of the LED to the 13th pin in the Arduino, and the negative of the LED will be connected to the ground of the Arduino. So now this is how our connections are ready. So all we need is to do a connection. I'll connect this connector from the Arduino to the PC. Yeah, so as we can see that the connections is done, and now let us see the code for this module. So let's see the code. Yeah, so as we have seen the connection, now we will see the code. So here I have written the code already. So as you can see that I'm giving the input values of the pins from the Arduino. That is pin number 2 will be the flame pin, which is the flame sensor module, and the pin number 13 will be the LED pin. That is our output. And now as we are using only these two, that is one input and one output, we will be giving the pin modes, that is what pin should work how, to the Arduino. And in this, the flame pin, that is the flame sensor, will be the input, because flame sensor itself will give us the values like if there is fire or if there is no fire. And the LED pin will be the output. If there is fire, it will turn on, and if there is no fire, then it will turn off. So now the communication rate between them will be 9600 bounds. So this is a very basic number. Now we will set up the sensor. So if the flame state, like where do we read exactly? So it will be digitally read by the Arduino, and which is flame pin. So flame pin is where it will be digitally reading the binary numbers. So printing, if the flame sensor is high, that means the flame sensor is you know if the flame sensor is detecting any flame, yeah, if the flame sensor is detecting any flame, then the LED pin will be turning on. So that means the flame is detected. And else, if it is not detecting any flame, if there is no flame here, that means the flame sensor is low, then the LED pin also will be low. So the LED will be working as per the flame sensor module. If the flame sensor turns on, the LED will turn on. If the flame sensor gets turned off, the LED pin will be turning off. So that is how we are writing. So here we have given some delay, like 2 millisecond. I will change it to 1 second. So that is 1000 millisecond. So I'll verify the code and let us see how it is working. So yeah, it is done, and as we can see that there is no errors in our code. Now I will just upload this code in the Arduino, and as we can see that the communication port, that is the USB port, is not connected. And now I will select the correct port and I will upload the code in my Arduino. So when I have uploaded the code, the Arduino will be giving us the signal, which we can see here in the serial monitor. So when we come to the serial monitor, we can see that there is 0 for every second. So when I take some flame near to the sensor, the value changes to 1. So this is happening every second. So now again when I took out, it is again 0. So this is how the flame sensor will be communicating between the Arduino and the humans. So that is how we will do it. So now let us see how it is working after making the connections and uploading the code, and let us see the uses of it. Yeah, so as we have learned how to dump the code in the Arduino and how do we write the code. So now let us see the output of the module. So we have done connections as we have planned in the circuit diagram in the video's first part too. So now let us get some flame nearby the sensor, and whenever I'm getting the flame, the LED here is turning on. When I'm taking it out, the LED is turning off. And again, when I do the same, it will be turning on. It is taking a slight delay because we had changed the bound rate, that is the timeline, to the 1 second. So after 1 second of getting the flame nearby the sensor, the LED will be turning on. So as we can see that it is turning on whenever we are getting the flame nearby. So this is how it will be working. So now the question is, where exactly is this used? This we can use in anywhere where we can use it for safety purposes, like in fire alarm systems. So in coming videos we can make the fire alarm too. So now that's it for now. See you in the next video, robot builders.